This is a huge room, way bigger than we needed for this course because we have about 50 people. For some reason, the course was set up to allow up to 150. I think in the past, we've had maybe 70 or 80 people in the course. But anyway, that's not too important. The class, as you know, is EECS-317, Data Management and Information Processing. I'm Steve Tarzia. This is the first time I'm teaching this course, or indeed any course at Northwestern. So you're in for a treat, I'm sure. But I think many of you are industrial engineering, management sciences undergrads, or have this course as a required course. But that's only about half, I think, of the class. The other half is from a variety of disciplines. And so in this lecture, I'm going to introduce the outline of the course, what topics we're going to be covering, also how the course is going to be structured. But first, let me try to introduce the topic really quickly. And so, by the way, I'm going to be kind of tethered to this area around the podium because I'm trying to record a video with this microphone that is on a short cable. Okay, so I apologize for not being too entertaining. I can't use the full stage, at least not today. Okay, so we're going to learn how to deal with real-world, complex, messy data. And the tool we're going to use to deal with it is SQL Relational Databases. So SQL, I'm going to pronounce SQL. You'll get used to that, and that's how most people pronounce it. But this course is not really a databases course exclusively. There are two other courses taught by electrical engineering and computer science that talk about databases. This is about using databases, and I think the second half of the course we'll get into that. But the first half of the course is some preliminaries about data itself, how to deal with various formats and so on. So we're not going to teach you how to create a database management system, like the internals of how a database works, but rather how to create a database using your data. And that's kind of confusing because the word database is used both to mean like a set of data and also a database management system like MySQL or Oracle. Those are called databases, but really those are database management systems. Okay, so at any time throughout these lectures, stop me if you have questions. I think there's plenty of time for that, at least in the first lecture. Now, relational databases are, how many of you have heard of a relational database before? Or does that mean anything to you, SQL or relational databases? I think based on the prerequisites, I assume that none of you have used it. I asked in the survey, and maybe 2 people said that they had used a SQL database, which is what I expect. So one of the things I'm trying to do here is explain what it is, or what those are. So relational databases are a technology that's used in pretty much every real-world software application and in a lot of complex data analysis situations. I'll show in this first lecture what the difference is between a very simple data analysis that you can do in Excel or Matlab without using a database, where basically all you need is a spreadsheet or a table, and contrast that to a more complex analysis that you can do with a relational database where you have multiple tables and cross-references and so forth. So after you take this class, you'll be able to deal with those more complex types of data that have all kinds of relationships between the different elements. So another thing databases do is let you store the data for long-term use. So you guys probably know that in computers you have memory and you have files, and those two are different because the memory is kind of short-term and files live for a long time, right? So databases are like files in that way, like file systems, in that the data lives forever, or as long as you want it to. It lives after you turn off the computer, after you stop your program. But unlike a file system, it gives you a lot of additional features. So you can query individual pieces of the data. In other words, get to the parts of data that you want to get to a lot more quickly than you can with a file. With a file, usually all you have is a set of a folder tree that you can navigate through, and you have a file name that kind of tells you that's all you really have to navigate through your file system. And then within the file, you just have a long block of data, right? And that's not too helpful if you need to find just one piece of data, right? But databases give you a structure that lets you find exactly those few pieces of data that you need to quickly do your analysis. So that's queries and indexing. And so another feature that databases give you is the ability to deal with concurrency meaning that you have multiple applications or users trying to use that data at the same time. For this application, I mean, for this course and for the kinds of projects you guys have been working on, that maybe is not too important, but if you were building, for example, an e-commerce website based on a database, that would be important because you'd have multiple people, placing orders and viewing their data at the same time, and that all needs to be managed in a way that doesn't have people kind of like overwriting themselves. And then we also have crash tolerance in a database where things are carefully managed so that if you're in the middle of adding new data and suddenly the machine turns off or whatever, then things don't get screwed up. So another way to look at this course is that it's a small piece of data science. Maybe not a small piece, but a portion, maybe a third of data science. It's the data management part. Data science is also statistics, such as IAMS 304. Some of you have taken that or will take that, in statistical methods for data mining. We also have some courses in the EECS department, like 349, which is on machine learning. So statistics are an important part of data science. We're not going to cover statistics, but we're going to talk about just the data, which is a prerequisite for really doing statistics with that data. We're also not going to be talking about visualization, which is another branch of data science. And, but maybe in future iterations of this course, I might get into that because I actually haven't found many courses here that do deal with data visualization. You guys can correct me if I'm wrong. Has anyone taken a course that dealt with data visualization? What was it? Okay, so yeah, so this is the one I listed. It's taught by Frank Neri in the Psychology Cognitive Sciences, presenting ideas and data, which is actually a very good course. People like it. But I don't know of anything that's really geared toward engineers or required for engineering majors. Okay, so to summarize that again in a different way, you'll learn how to answer questions about the past using complex data sets. I say about the past because we're not using statistics to create a model to predict the future. Like I said, that's covered in other courses, but we'll just be looking at the data. These are the facts. What does it tell us? Okay. So like I said before, Excel is great for simple things, but doesn't let you do everything. Pretty much, based on the survey, pretty much everyone has used Excel and Matlab. And I'm not trying to dump on those tools. They're good for what they're used for, but I'll show you pretty quickly that they can't be used for really complex things. So a spreadsheet is just a 2D array of data, but often you have that doesn't work for the data you have because you want to have one-to-many or many-to-one relationships. Like for example, if you're trying to represent customers and orders, a single customer can have multiple orders. So how do you represent that in a table? Okay, you could have a table of customers, but then within that table, you could try to create multiple columns, one for every order, but then you'd have a different number of columns for each person, or you could try to put that in a separate tab in the spreadsheet, and that would be the cleanest way to do it. And that's where it starts to become more like a database, where you have multiple tabs, one for each type of data. But then when you do that, it's hard to actually do calculations that involve those different tabs, because what Excel is really good at is just summing stuff down a column, right? And then similarly with MATLAB, the limitations you have there are that you're stuck with a matrix-like data array format, and it's hard to put strings in there, and basically anything other than numbers. And with Excel, one of the things you always run into is that people put all kinds of weird data in their spreadsheet. There's nothing to stop you really from typing whatever you want into a cell. And that means that later on when you want to do an analysis, you can't really rely upon the data. You don't really know what you're going to get out of a single cell in a spreadsheet, so it's hard to actually do a calculation without running into a lot of errors. Okay. And one final thing about spreadsheets is that the data and the analysis are kind of stuck together. So here's an example of a spreadsheet that is kind of messy and has all kinds of problems. And this is kind of a straw man argument because this is not a good spreadsheet. So there are better ways to use a spreadsheet than like this, but even if you are really good at using spreadsheets, you're going to run into limitations. But here you see, for example, that, I don't know if you guys can see my pointer. OK. So like on the left, someone's trying to represent a one-to-many relationship of like this one person has multiple orders. This table is supposed to represent orders like from a store. And then you have like on the date, in the date column, like there wasn't anything enforcing that all the dates had to be in the same format. So like some of them were put in incorrectly and they defaulted to like January 1st, 1900. Same thing goes in the second date column. And then there's like a page number in here for some reason. Like there isn't anything that enforces the fact that we would expect to see real data on every row. Sometimes you have blank rows. That's kind of messy. And then you have these totals down here. So this 9342, whoops. So this is an example where combining the data and the analysis in the same sheet becomes kind of messy because if you wanted to add another analysis to the numbers here, like you would have to put it somewhere else. There's only one logical place to put analysis of this whole column in the spreadsheet. OK, I think that's as much as I'll say about that. But in the real world, you may have very complex data. So I don't expect you to be able to read this, but this is an example of a really complex data set. It is the PatStat, European Patent Office's International Patent Database. And I'm sure you guys know what patents are, but what makes this complex is the fact that patent documents can be very different. They're all text documents. They all have a title and like authors. But then beyond that, they can have all kinds of different things. So, and also this database covers patents from different countries. So every country has its own conventions for what to include in a patent application. But this data vendor was able to create a database for this very complex data using 29 tables. And that's what each of these boxes is a table. So for example, this purple one in the middle is the application. Oh, why isn't that? That's too bad. OK, I thought I was going to be able to zoom, but it doesn't. Oh, actually, yeah, OK. Yeah. So this purple one in the middle is the actual patent application, which has things like the filing date and the year. And then like associated with it, you can have different people that have names and addresses. You see that in these green boxes. And like those people are represented in different tables because you could have like 3 or 4 people associated with a application. And so putting them in a separate table allows you to do that cleanly. I'm just giving an overview here. Like we're going to spend a lot of the course talking about this kind of modeling. I'm just trying to give you a flavor for it now. And then you have this big gray column over here are legal events associated with an application. Like for example, first an application is filed, and then later the review might start, and then it might be approved for a certain term. That might be extended later. Those are all events associated with a patent application. And so you want to record every one of those independently. But if you're trying to do all that in one table, I don't even know what it would look like. It would be like a disaster. Like if you're trying to do that in Excel, in other words. OK. And this is also a big data set. So I was working with this over the summer, and it was shipped to us on 6 DVDs, which are these round things you may have seen in the past sometime. And after I unzipped it, it was 119 gigabytes of text data. So that's enough to fill up like an entry-level MacBook, or on the file system, and it's certainly way more than you'd have available in memory. So normally, like on a laptop, you'd have at most 16 gigabytes of memory, meaning that if you're using Excel or Matlab, you couldn't even load all this data in because the way those programs work is that they use memory to store data, right? So you have to use the file system. You have to keep stuff on disk and then pull it off disk only as needed, and that's what that's one of the things a database allows you to do. Okay, so I explained some of the challenges or the problems with Excel and Matlab. You may be wondering, okay, but there are all these other more advanced programming languages out there. Like, don't they solve these problems for me? And the answer is kind of, but not entirely. So and some of you I think have some experience with like object-oriented languages. Most of you don't, but which is why I'm explaining this. But like in Python, C++, Java, those kinds of languages, you have objects which let you represent complex relationships, and you can have, so you can model the data in these languages. The problem is that you don't have a way to store it persistently. You're working within memory, like I said, so you're limited in the space that you have. And there isn't a way to search through that data, to index the data, so that if you want to, for example, get all the patent applications from 1996, and you were storing them in Python, it's in objects, then you'd have to either write code that handled that indexing for you, which would be a lot of work, or you'd have to go through all of them to like check the dates to get the ones you wanted. And then similarly, there isn't an easy way to do that searching, which we call querying in a database. So the things that a database provides are like the italicized things on the right here: scalability, persistence, indexing, querying, concurrency. And I think we'll come back to those. Again, this lecture is just an introduction. But all those things are like common things you want to have with data that are kind of difficult to do on your own from scratch, that all these different programming languages don't provide on their own, but the databases provide. And generally, so what you end up doing if you're working in Python, C++, Java, MATLAB, R, in all those languages, there are ways to connect to databases, to write queries to pull out the data you need, and then you work in that whatever language it is that you're working in. But the database is there behind the scenes to store all the data, to keep it organized, to let you get just the pieces you need really quickly. And like I said, what you'll be learning in this class basically is when to use databases, how to load data into databases, how to get data out of databases. And then that'll let you do all kinds of analyses. All right. So as I alluded to, you want to answer questions with data. All right. So you can call that descriptive analytics, meaning that you're answering questions using data from the past. And so here are some examples. Or here's one example that's actually spelled out in SQL. So imagine that we have a database of, and this is like kind of messy, right? So there are good things about this and there are bad things about this, and I'll describe that a little bit. But let's say that you have a database that represents an online retail store or like a brick and mortar retail store or whatever. So you have customers, you have orders, you have different product SKUs, you have inventory, you have shipments, you have refunds, you have all these things related to a business. And there are all kinds of questions you want to ask. So you don't want to, whenever you want to ask those questions, you don't want to like start from scratch and build a database or like collect data. You don't want to start going through invoices and files to answer any of those questions. It's really convenient to have one database, one data representation that allows you to answer like any question you might have reasonably about your data. So assuming you do have a database, you can answer all different kinds of questions about the data, such as these three, right? So the first one, as an example, where did our 10 biggest customers live in 2007? What you see below is an SQL query, a SQL query, that answers that question, assuming a certain format for the database. But then you can also answer totally different questions, like, for example, how many widgets are left in stock? What's the average price of a certain type of product we have, like shares? So by the end of this course, you'll be writing queries that look like this. So I'm actually just going to walk through this really quickly to give you an idea of what it does. But select is an element that means it's kind of like get. It's an instruction to get data, and you're getting the name, a customer's name, customer's city, and a customer's province I use the word province because state is kind of a vague term that could mean all kinds of things. And it's coming from 4 different tables. There's a customer table, there's an order table, there's an order item table, which are like the things in that order. And then there's the product table, which are like just the description of the products. So using those 4 tables, and I'm not going to go into details of like what the right part of this right-hand side of that is, but we're applying filters. So we just want the date of the order to be between January 1st, 2007 and before January 1st, 2008. We want to group them by the customer IDs. In other words, we want to take all those orders for a single customer and collapse them together. Because again, the question was the 10 biggest customers, meaning like the customers that ordered the most stuff from us in terms of dollar value. So for every customer, we want to know how much did they spend in 2006. So we group by the customers, and then we want to order them by the sum of the item quantity times the product price, which gives you like the how much they spent for all those orders together. And actually, I think I missed a word here, which should have been descending. We want order descending to put the biggest ones first. And then we just want 10 of them. That's what that limit 10 is. Okay, so that's SQL. Great. I don't know. I mean, it's a little bit intimidating, but at the same time, answering that question in any other way, in any other language, would be a lot of code, and it would be more difficult than this, I think. Okay. So I mentioned earlier that database management systems are like the software that runs your database. And you've probably heard of at least one of these different like brands or particular database management systems, like Oracle, Microsoft SQL Server, MySQL, Postgre. There are also these like smaller ones called SQLite and Microsoft Access, which just work on like a single machine instead of being shared among different applications. So often they are accessed by multiple users at the same time. Those are the first ones, not SQLite and Access. And so like what you do is like kind of like log into the database with a username and password, and you have to know what the host name is. And yeah. So in that sense, it's different than using data that's just in a file on your computer, right? And like I said earlier, you're typically going to be working in some programming environment, whether it's R or Python or MATLAB of your choice, and you're going to be using a client library within that software to connect to the database. You're going to write SQL code to get the data you need. It's going to come back to your main environment, and you're going to use that, whatever language that is, that you were originally working in, to actually finish your analysis. So SQL is like an extra second language that you're going to be using alongside whatever the main language is that you're using. Although in this class, a lot of the early assignments are just going to be SQL because you're just going to log into a database, make queries, and just get the data and not do anything with it, just kind of look at it. Okay. This is the course outline I've come up with. It's a little different than previous versions of this course. I looked at the reviews for the course. I talked to Jill Wilson in IEMS, and I think I got a pretty good sense of what elements that were previously taught were not really necessary, and we're just kind of bogging down the course. So I trimmed some things out, and we're going to spend a little bit more time on things that I think are practical and useful. So this should be a better version of 317. That's my intention anyway. So the first half of the course is about data, the low-level details of data, so different numeric formats. Some of you may have seen some of this stuff, in which case it'll be easy. Probably most of you have not. So how are numbers represented in binary? I'm sure you know the computers use binary representations, but like what does that really mean? How are integers represented? How are floating point numbers represented? Fixed point numbers, different levels of precision, dates and times. I think these are all necessary to really work with data without messing things up. Because when you actually get to the database, you're going to have to decide, okay, for this particular value, how am I going to store it? It's not like a spreadsheet where you just have a cell that's like a white box and you put whatever you want into it. you have to say ahead of time, okay, this is going to be, for example, a 64-bit integer or a 32-bit float. And so you have to know ahead of time what that means for the kinds of data you can store in there. We're also going to talk about text encodings, like ASCII, Unicode, UTF-8, special characters. So this is important when you're working with documents and different languages. You want an emoji in your code. You have to not use ASCII, things like that. And then you're going to learn how data is organized in files, like CSV files, XML files, JSON files. So this is going to be useful if you ever actually need to get data from someone. People don't give you a database usually. They give you files, and you have to load that into a database. And often that's kind of a pain. So you're going to get some practice dealing with that, and also dealing with messy data. So someone gives you a file, and it's supposed to have numbers in one of the columns, and it doesn't always have numbers. Sometimes there are weird letters thrown in there, or empty values, or whatever. All right, so the second half, or 2/3 of the class really, is on SQL Relational Databases. So the first part of that is what's called data modeling, which is given some generic description of data that you have in your head, or that you have in files, or that you have in paper. How do you turn that into a database? What tables do you create? How are what columns are in the tables? How are the tables linked to each other? What happens when you delete a row? Where are you going to add indexes so things are fast? Although actually indexes are covered later on in the next bullet point. But so after data modeling, which isn't really done in SQL, that's kind of like a pen and paper exercise where you draw those boxes, those 29 patent boxes I showed you. That's a data model. So after you learn how to do that, we'll actually use SQL, structured query language, to get data from an existing database, create databases. And there are different steps involved in learning how to do that, using multiple tables, using subqueries, temporary tables, indexes, and finally execution plans, which is a way to optimize your queries. Because if you don't understand what's going on in a database, design a database well, if you're dealing with 120 gigs of data, in that patent database, it'll just take forever to get what you want. Database optimizations are not about they're not nice to have things that just make things go smoother. There's a difference between actually getting the job done and just never getting it done. And depending on how things go, I may include some other topics. And you guys should feel free to suggest topics by email or in office hours. And I'll definitely consider that. So at this point, I'm going to pause and ask if there are any questions about the course content. OK, that's fine. The next thing I'm going to talk about is logistics of the course. So I'm going to try to do as much as possible on Canvas, just because it's convenient to have everything in one place. Right now, there's a syllabus posted. There's an assignment posted, which isn't really it's not a graded assignment, but I have a reading posted there, a PDF on number representations. I think it's about 14 pages long. It's pretty simple. Well, no, it's not simple, but it's 14 pages long, which is not that long. And I'm going to be posting lecture slides there. Like I mentioned at the beginning, I'm creating videos, and I'm going to try to post videos of the lectures. I'm not sure if that'll be helpful for anyone, but if you need to skip a lecture or something, then it might be useful. I'm going to have office hours on Tuesday, Wednesday, and Thursday, 2 to 5, so plenty of time for office hours. I'm in tech on the 3rd floor, L360. We have a TA, Masood, who is not here today, but he's a half-time TA. He's being split between this course and another database course. So yeah, in computer science, we have a lot of students suddenly. So a lot of the courses are huge and need a lot of TAs and stuff, but we don't have enough TAs, unfortunately. But I'm going to try to get some graders and stuff to help with the workload. He will announce his office hours through Canvas, and you'll get an email about that. Okay. Books. Okay, so this is the good news, I think. We have different books this year, or we're not using the same book. These are, I think, much better, more clear books, a little more practically oriented rather than computer science theory oriented. They don't talk about, again, like I said, they don't talk about how database management systems are built. Like if you were to go work at Microsoft designing Microsoft SQL Server, you'd need more information that was in these database books. But if your goal is to make your own database, to load your data into a database, then this is the information you need. I think they reach about 600 pages, but the text is pretty big, and we're only going to read about half of the first one, the one on the left, but probably most of the one on the right on SQL queries. Okay. So I apologize for not having this information about the books available sooner, but I actually was just told I was teaching this class a week ago because the previous person had visa trouble, so couldn't teach the course. So yeah, I kind of have been scrambling to adjust things to suit the way I want to teach it. But I think we'll be good with these books. Okay, grading. You guys probably are interested in this. We're going to have homework, midterm exam, and a final exam. Yeah, I think this is pretty standard. What probably is more important is what is in the homeworks and what are the midterms going to be like and what are the finals going to be like. I have a tentative sketch of what the homework assignments might be, which I don't know if we have time. I guess I do have time to go over them right now. But so the first one is just going to be looking at data sets online and identifying different data types and trying to find problems just to get used to the idea of looking at real world data sets, because actually they are quite different than probably what you've seen in other courses where a professor gave you a spreadsheet or just gave you a data file and said do a regression. Okay, that's great, but often if you're trying to do an analysis in the real world, you don't have a table with numbers that you can just run through a regression tool. And then second homework is going to be on representing numbers, which is the first real topic of the course. So, integers and floating point and all that stuff. The third homework assignment is going to be on data modeling. So you'll have to come up with a set of tables and columns to represent a certain data domain. And for a lot of these assignments, I'm going to try to come up with different variations of the assignment for different folks. And then for the fourth assignment, you're going to write SQL, connect to a remote database. I'm going to set up a database with a large data set, and you'll be able to log in and kind of browse it, but also answer specific questions from the homework assignment, writing queries. That should be pretty interesting because it'll be, like I said, a really big data set. And then the final assignments, and this is all tentative, but so far the way I have it sketched, the final assignment is 2 parts because it's a bigger assignment, and it's going to involve actually using the programming language of your choice, so maybe R or Python or something else, but those would be the easiest languages to load data from files like CSV files, XML files, JSON files into a local database, probably SQLite, and then add indexes and do queries. So that's kind of a end-to-end assignment where you're starting from data that is perhaps a little bit messy. You're loading it into a database, you're running queries, you're answering questions. So that's kind of the capstone of the course. All right, any questions about the logistics of the course? Okay. All right, so like I said before, there is a reading assignment for next lecture. It's posted on Canvas. There's also a link here. It's a 14-page PDF on representing numbers and computers. Yeah. So if you really know that stuff already, it'll be pretty quick. If not, it'll probably take about 45 minutes to read that. And that's all I have. So that's It's about 15 minutes too short. But for the first lecture, I don't think that's a problem. Any other questions? For the midterm, I don't, but I will. Are any of you planning to travel in the middle of the quarter? Is that? Yeah. My guess is it'll be around the middle. Let's see. Okay. For how many people is it really important to know the exact date of the midterm? 1, 2, 3. Okay. Since it's more than one, I'll figure that out by the next class and let you guys know. Other question? Yeah. No, you will not need to bring your computers. I don't think so. If there may be 1 or 2 lectures where that's the case, but I'll let you know ahead of time. Okay. All right. Well, thank you all. And one more question. Yes, you need to buy both of the books. They look similar, but they actually cover different topics, and they're by the same authors, sort of. So the first book, the book on the left, Database Design, is really just about data modeling, and the book on the right is about SQL queries. So the book on the left doesn't include any real syntax for writing queries. All the syntax is on the right, and the reason that there are they didn't combine them in one book is because for some people just deal with existing databases, in which case all they need to know is the stuff in the green book on the right. How do I get data from the database? But for this course, we're also going to talk about how to model data to create a database, and that topic is covered in the blue book on the left. But we're not going to do the whole book because it includes a lot of stuff about data applications. So it's kind of geared toward people who are writing software applications, which like for example, if you're designing a website and you want to know how to create the database to support that, you want to think about what different screens are there going to be on the web page and how are users going to interact with it. I think that's a little different than what you guys are going to be doing with databases for the most part. I mean, some of you may do applications, but that's not really covered in this course. One more. Yeah. Yeah. Okay, if you're in electrical engineering, you're a master's student? Yeah. If you're a master's student in electrical engineering, then this course counts as one of the 9 300 level courses that you have to take. It does not count as one of the 6 core electrical engineering courses because it's not really electrical engineering. Other questions? Okay, let me turn off the mic, unless you want everyone to hear.
Okay. No worries.